Now let's talk about radian measurements. Now when you are using calculus, then in calculus default unit is radian. All angle measurements. Now this is very, very important to understand, right? Now let's try to understand radian as such. If I have a circle, in that circle, I could always relate arc length to the radius and the angle. So if, say, the angle here is given to you as theta, A is the arc length, R is the radius. In that case, we know A equals to R theta. The arc length, that means this length, is equal to product of R and theta. Now, if A equals to R, in that case, what happens? If I write A equals to R, basically I can write from here theta is A over R, right? If A equals to R, that means R over R will get 1, right? So theta is A over R, so we can say 1 radian is the angle for which arc length equals radius. Correct? This is important to understand. So if A equals to R, you can substitute and get theta equals to 1 radian. Now you can also appreciate here that theta is a ratio, right? In radians, A over R, same units. So there are no units. So radian is ratio. Basically no units. We write radian for convenience. So if I just write a number, let us say we say that the angle A is equals to, let's say 2.5. Without unit, it is assumed to be radians. Now this is a huge concept to understand. Do you understand that? Okay. Now from this particular definition that A equals to R theta, we can actually come to know what theta is for one full circle, right? For one full circle, we know circumference is what? Is 2 pi r, right? That is for full circle, what is theta? What is theta? This is what we need to find. In that case, we can again use the same equation, which is A equals to R theta, right? So let me use that. Equation A equals to R theta. Now for full circle, A is 2 pi r, right? So we get 2 pi r equals to R theta. Now clearly R and R cancel. So we get 2 pi is equal to theta. So in radians, full circle means angle of 2 pi radians. Okay. So one thing important in calculus, we always use radians. Second, what we just now found is full circle angle is 2 pi. Correct? Full circle angle is 2 pi. Now, in case you are working in degrees, if you are working in degrees, then what you learned is that the full circle is 360 degrees, correct? So that means the relation between degrees and radians is what? Is 360 degrees equals to 2 pi radians, correct? So that becomes the relation. So what we can, another thing conclude here is that if you have to convert the units, then 2 pi is equals to 360 degrees, or pi is equal to 180 degrees, right? Now this conversion is very, very useful, and we are going to use this conversion a lot. Since you are familiar with degrees, radian might be a new unit for you. So, but use pi equals to 180 degrees for conversion. For very useful, let me write down angles in degrees and radians for you, especially the ones which we are going to use many times. Let me give you a few examples here. So let us say if the angle in, let's just say angle in degrees and in radians. Okay. So we'll try to write down few relations between degrees and radian angle. So if angle in degrees is 0 degrees, in radians again it is 0, we'll use this conversion factor, correct? If I use 180 degrees, I have radian value of pi. Half of 180 is 90 degrees, so it should be pi by 2. And half of 90 is 45 degrees, so it could be pi by 4. Does make sense to you? Is that all right? Perfect. So these are a few easy ways of figuring it out. Now if I give you another angle, which is, let us say, 1/3, I know, forget about the scale kind of thing, right? Let's look into next set now. So if I say pi by 3, it means what? Pi by 3, pi is 180, 1/3 of 180 is 60 degrees. Does it make sense? If I say pi by 6, we are doing the reverse now, right? Divide 180 by 6, what you get is 30 degrees. Does make sense to you? So you could go the reverse way. So you could go the reverse way, kind of like this. Do you see that? In general, if I say you have to convert 72 degrees to radians, what will you do? Well, easy method is 72 is in degrees. You do not want degrees, you want radians. You're going to use this ratio, multiply this by something which is radian on the top and degree below. So this factor pi over 180 will always be 1, correct? So if you multiply this by this factor, you're not changing any value. Does make sense to you? So that is how you could do it. And you can simplify this to get the result, dividing both by 6, for example. 6 times 30, right? 6 times 1 is 6 and 2, 12. And further we can divide by 6. 6 times 5 and 6 times 2. So what you get here is equal to 2 pi over 5. So 72 degrees is 2 pi over 5 radians. Does make sense to you? Correct? Now, if I say, let us say 2.5 radians, and if you have to convert to degrees, how will you do it? Well, the easy way here is, you know it is 2.5 radians. You have to multiply by a factor which has radians in the denominator. So we could divide this by pi radian and times it with 180 degrees. Does make sense to you? So that factor is going to give you the result of 2.5 radians into degrees, correct? So let's multiply. So we get 2.5 times 180, which is 450 over pi in degrees. Do you understand? Right? So you could actually get answer in decimals. So we'll do 450 divided by pi to get the answer as 143.24 degrees. Is it okay? So you could convert the radians to degrees by multiplying by a factor of 180 by pi. Correct? So the easy way is, if you have to convert from radians to degrees, in that case, since you have to convert to degrees, the factor is, for this, the factor is degrees on the top, 180 degrees divided by pi. Do you see that? That is what you have to do to your radian value. But in case you want to convert degrees to radians, in that case, what is the factor? If you have to convert degrees to radians, you want radians on the top, so it should be pi over 180 degrees. Does make sense to you? So that becomes the conversion factor for you. Perfect. So this is the conversion factor which you should remember. Now the next thing which we'll talk about is how to sketch angles in radians, right? So how to sketch angles in radians, this is what we'll now discuss. So let me make two kinds of sketches here. We'll now see how to sketch radians, angles in radians. So we sketch angles in radians. From this particular graph, if I'm sketching radians, this is 0, this is pi, we know, that is pi by 2, and pi by 2, 2 pi by 2, 3 pi by 2. Is that okay? You can also call this as 2 pi, 0 or 2 pi, correct? Now, if I do half of this, let's say half of this, then what I get? I get multiples of pi by 4, correct? I get multiples of pi by 4. So this becomes pi by 4, 1 pi by 4. This is 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, and 8 pi by 4. Does it make sense to you? 8 divided by 4 is 2, you get 2 pi, correct? So you get 8 pi by 4. It is so simple. You don't have to think much. Now, let us take another example here. And now we'll sketch pi by 6 angles. Pi by 6. So if I have to do pi by 6, that is to say, here we want 1 pi will be into 6 portions. So starting with 0, I want pi by 6. So basically, I want 6 pi by 6. That becomes pi by 6. I have to divide this into 6 equal parts, right? So I have to divide this into 6 equal parts. So 1, 2, 3, 4, 5, 6. Do you see that? Those become the 6 equal parts. So if I draw these lines, one of them is definitely this line, and then 1, 2, 3, 4, 5, 6. And I can extend them, right? So I could have this, 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 and this. Is it okay? So each is pi by 6. So starting with 0, this becomes pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6, 8 pi by 6, 9 pi by 6, 10 pi by 6, 11 pi by 6, and 12 pi by 6. Do you see that? So easy. That is how you sketch your angles in radians. Nothing can be simpler than this. I hope that is well taken, correct? Now you'll notice that these lines are pi by 3 apart, right? So the multiples, even multiples, are pi by 3 apart. Do you see that? So these are pi by 3 apart. Correct? You could write them as pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3, and 6 pi by 3, which is 2 pi. Do you see that? So you could easily sketch all pi by 4 multiples, pi by 3 multiples, or pi by 6 multiples using the strategy of dividing each quadrant into those many parts. Do you get an idea? So I hope that gives you an idea of what the angle in radian is. How is it related with arc length? That's the beauty. How is it related with degrees? How to convert from radians to degrees and degrees to radians, and how to sketch them if required. Correct? Now onwards, when we talk about solving equations, we'll find angles in radians as we are preparing ourselves for calculus. So with that in mind, let's move forward. Thank you. Now let us try to understand how to solve trigonometric equations. We'll take simple equations and we'll take domain of theta to be from 0 to 2 pi, right? So for all our calculations. As soon as I write 2 pi here, it should be clear that we are working in radians, correct? So let's take few equations. Let's say the equation could be sine theta plus 1 equals to 0. We can say cos 2 theta equals to, let's say, 1. And let's say sine square theta equals to, let's say, equals to 1 over 4, right? So let's solve these equations one by one and try to understand the strategy. Now, the very first one given here, sine theta plus 1 equals to 1, basically means sine theta equals to 0. So whenever you have an equation with sine theta equals to 0 or sine theta equals to plus or minus 1, it is a good idea to use the sine curve and find the solution. Sine curve basically is like this, as you know, with a time period of 2 pi, and it has 3 zeros. These are your 3 zeros, and they are at 0, pi, and 2 pi. And therefore, the solution is theta equals to 0, pi, and 2 pi. Perfect. Now, when I say cos 2 theta equals to 1, we're actually working in the domain of theta equals to 0 to 2 pi. But if I say 2 theta, the domain increases, and 2 theta should be between 0 to 4 pi. You just multiply this by 2, and so the domain increases. Now, for cos curve, whenever you're working with 1 or minus 1, the cosine function, you could sketch and get your solution. For cosine function, it starts with 1 and it ends with 1. And it does have period of 2 pi, correct? When you say 1, it means we are actually looking for 2 theta equals to 0, or this is 2 pi. Now, since we have to go forward till 4 pi, you need to understand that we have to take 2 waves, right? So it's kind of like this, and it's again 1 at 4 pi. So 2 theta equals to 0, 2 pi, and 4 pi are our solutions. So theta in radians will become, you divide them by 2 as 0, pi, and 2 pi. Do you see that? So that becomes the solution for the second equation. The third equation here is sine square theta equals to 1 over 4. So you can write sine theta as equals to square root of 1 over 4. Whenever you do square root, you should take both plus and minus into consideration. And so we get plus minus half as our result. Now, plus minus half, that reminds you of a special triangle, which is pi by 6, pi by 3, right? So this special triangle where the angle is pi by 3, pi by 6, and the sides are 1, 2, and square root of 3. Since you're looking for plus minus half, you have to look for also the all the four quadrants, right? Within 0 to 2 pi, as you know, that all are positive in quadrant 1, sine in 2, cosine in 3, and tan in 4. Now, if you're looking for plus minus half, that means we're looking for a solution which is half, is pi by 6. So we're looking for these solutions. Do you see that? We're looking for these solutions. We are looking for these four solutions. All give you plus minus half. How do you get all of them? Well, theta is equals to, for half in the first quadrant, gives you pi by 6. In the next quadrant, it is 1 less than pi by 6 or 5 pi by 6. Now here it is 1 more than pi by 6, 7 pi by 6. Now here it is 1 less than 2 pi, correct, or 12 pi by 6, which gives you 1 less as 11 pi by 6. So you get these four solutions. Do you understand? So taking simple equations, that is how you would actually get different solutions. Now let me take few more examples which could be slightly more tricky. Now if I say that, let's get back to this with cosine 2 theta, just as we did here, right? So let's take 2 of sine 2 theta, let's say, equals to 1. How are you going to solve it? Since we are talking about this, we can write this as sine 2 theta equals to half. Now we are talking about 2 theta, not theta. So our domain changes. Our domain will become, for 2 theta, it is going to be between 0 to 2 times 4 pi. Is that okay? And the same thing, same situation. However, we have to go for one more cycle. So in this case, we'll say 2 theta is equal to pi by 6, 5 pi by 6, 7 pi by 6, 11 pi by 6, and then we have to add one more cycle to it. That is kind of important to understand. One more cycle to it. That is to say, you have to add 2 pi to each one of them. Adding 2 pi means 12, right? So 12 plus pi is 13 pi by 6. 12 plus 5 is 17 pi by 6. 12 plus 7 is 19 pi by 6. 12 plus 11 is 23 pi by 6, correct? Now theta is going to be half of these. So if you do half, you get pi by 12, 5 pi by 12, 7 pi by 12, 11 pi by 12, 13 pi by 12, 17 pi by 12, 19 pi by 12, and 23 pi by 12. Do you see a small change which I made in the equation resulted into a huge difference in number of solutions, right? So that is a very, very important part to understand. Now if I give you an equation which is, let's say, cos 2 theta is equals to 3, well, we know that that is not possible, so no solution. So at times for equations, so we see that cos 2 theta equals to 3 has no solution. And now you understand that the range for cos theta is between plus and minus 1. And similarly, sin theta value also varies between plus and minus 1, correct? So those are the limits for these functions. It is always less than absolute value of 1. Perfect. Now let us use calculator to find some values in radians for a given equation. So let's take few equations like, let me take one as sine theta equals to 0. Let's say 25, right? In that case, theta is equals to sine inverse of 0.25. Now we can use calculator to calculate these values. first thing of course is you have to change the mode to radians, right? So for us 4 is radians, and now we will do sine inverse of 0.25. Shift sine inverse 0.25 gives us a value of 0.25268. Let me write this as 27. So that is one of our solutions. As you have seen, sine is actually positive in quadrant 1 and in quadrant 2. So there should be another answer also. The other answer will be theta equals to pi minus whatever you got, which is 0.2527, correct? So we have to find that answer also. So it is pi minus 0.2527, which is equal to 2.888. So you get 2.888. So for sine theta equals to 0.25, you get two solutions. One of them in quadrant 1, 0.2527, the other one in quadrant 2, right? So that is how you can use calculator and find the answers. So let's take one more example. Let's find out the answer for tan theta equals to, let us say, 1.27, right? So I'm taking tan theta as 1.27. I need to find solution between 0 to 2 pi. So tan is positive in quadrant 1 and in 3. Time period for tan is pi. So whatever you get in quadrant 1, you can add pi. Theta equals to tan inverse of 1.27. So that is, we have tan inverse of 1.27 equals to, it gives me 0.9037. That is one value of theta. So let me call this as theta 1. The other value will be pi plus this much, since it is positive in quadrant 3 also. So we can do pi plus 0.9037. Okay, so we'll add pi to this, which gives us 4.0537, correct? So these are two solutions for tan theta equals to 1.27. Anyway, what you understand here is that in calculus, all the calculations should be done using radians, and now you understand how you can find different solutions for an equation in radians. So as an exercise, let me write down this question for you. Let it be sine 2 theta plus 1 equals to let's say 2 over 3, right? Let's say 2 over 3. So find solution for this in the domain theta between 0 to 2 pi. Correct. So let this be a question for you.